Okay, this chapter's huge. I think in later editions of the book they broke this chapter up into a couple of different things. But there's two main things in this chapter that you're going to see on May 10th. One of them is how to design and create a confidence interval, which we've just been working on. And the other one is this thing called the test of significance. Now, what's the difference? Look, I have no idea what the average length of a name is at Elk Grove High School. No idea. So what do? I take a sample out, I find my sample mean, and I build a margin of error around it to try to predict what the true mean of all of them is. That's what we just did, a confidence interval. Well, what do we do if some clown thinks they already know the right answer? You don't even need to go do any work. I'm telling you what the right answer is. Some clown comes up and says, you know what? Don't worry about it. The average length of names at Elk Grove High School is 5 letters. I already did my study, I already did my analysis. 5 letters, that's it. What do you do then? Well, we could do a confidence interval. We just talked about this. We could do a confidence interval. Is 5 probably going to be in that confidence interval? No. Those are all our X bars, right? So we can do a confidence interval. 5's probably not going to be in that confidence interval. We'll say, you know what, you're wrong. 5 wasn't in our confidence interval. So that's one way to do it. But another way, and how we're going to do it more, is this thing called the test of significance or a hypothesis test. And you'll see why we want to do this, to try to prove somebody wrong. Okay? All right, a lot of fancy words, but here's the bottom line. Here's how this thing works. You say the real mean is 5? All right, check this out. I got a mean of 12.5. Now wait a minute. You think the mean of all of these is 5. I got a sample mean of 12.5. What were the chances of that? What do you think the chances are? If the real mean of all these are 5, what do you think the chances are that my sample mean would be 12.5? What do you think the odds of that are? Chances of that out? 0. No chance! Then this ain't 5. There's no way I could get 12.5 if this was really 5. Okay? We're just going to give overwhelming evidence. There was no way, 0 chance of this happening if this was true. And that's what a hypothesis test is. All right, fancy words. Okay, I'm going to assess the evidence provided by the sample about someone's claim. You said it was 5, I got 12.5. What are the chances? All right, tomorrow I'm going to give you all of the steps that we're going to take for a hypothesis test. Remember we did population parameter, assumptions, test statistic for a confidence interval? Tomorrow I'm going to give you all the pieces in the formal way we do a hypothesis test. Today I would just like you to kind of get an overall idea of what it's all about. All right, one of the steps that we do in a hypothesis test is we break it into a null and an alternate hypothesis. Okay? Null hypothesis, that's how we abbreviate it, H sub 0. And the alternate hypothesis is H sub A. Here's what the null hypothesis is going to be. Okay, we'll believe you. We'll pretend that the real mean is 5 letters. All you mock trial freaks out there. When someone is going into trial, the defendant, what do we assume that the defendant is during the trial? Innocent. Until we can prove them guilty. We're going to do the same thing here. All right, we're going to assume that the true mean of lengths of names is 5. Now the alternate hypothesis is what we think. And it's going to be one of these 3. Now, in this situation, we probably think the real mean is more than 5, right? So our alternate hypothesis, no, it's not 5, it's more than 5. And that's how we'll write our alternate hypothesis. If we would have thought it was less than 5, we'd put that. Or if we'd have thought, geez, 5's not right. I don't know if it's more or less, but I know 5's wrong. We would do this. We say U does not equal 5. So that's how we're going to write up our null and alternate hypothesis. We'll practice more of that later. But then here's the big deal. This is what we go and evaluate in a hypothesis test. It's called the p-value. And the p-value, okay, a lot of fancy words up here. It's, hey, what are the chances that I would get something that far away from what you said was true? So let's draw a picture of it. This is one of the things that you're going to be having to do tonight. So we're going to assume that what you say is true. So that means there's all these x bars out there. And all those different x bars have an average of 5. The true population mean. We got 12.5. We went and took our sample, and we got a sample mean of 12.5. So we actually know where that is. This person must really like me. Romero? I had to stick with this. We got 12.5. Okay. What were the chances of getting something that far away? That is going to be what we call the p-value. And if the p-value comes out just like 0 or just really low, you can't be right. There's no way I could get an x bar out there. Or, you know, what if they said it was 5 and I got a sample mean of 5.5? You're like, wow, it's pretty likely I'd get something like that. Then I wouldn't be able to call you a liar. Okay? Now, you don't have to do this tonight, but you actually have the skills to go figure out that z-score. What was that formula from last chapter? Z is equal to x bar, the sample mean minus the mean over. Now, what's the standard deviation formula for the sampling distribution? Sigma over square root of n. Let's go ahead and plug some numbers in. So 12.5 minus 5 over, I said we thought the population standard deviation was around 2.5. Let's say I took a sample size of 30. Go find that z-score for me. What is it?
1.55.
1.55? No way. 26. Anybody else get that? What do we have in bubbles here? Put 12.5 minus 5 in parentheses. 2.5.
16.4.
16 point. I've seen a lot more of that. 16.4. Wow. Is that thing even close to on our charts? No. We'd expect a z-score like that, right? You say the real mean's 5 and I got 12.5. So, you know, we don't even have them on our charts, but what is the chances? 0. There's no chance. That's the p-value. So we'd say, hey, I played your game for a little while. I got a sample that was impossible. My p-value was 0. That is definitive proof that it's greater than 5. The real mean's greater than 5. Okay? Questions, comments? Yeah?
What would you consider like impossible?
That's a great question. So what is good enough proof? What if I got something that it was like there's like a 10% chance of getting a sample mean like that? Are you going to stick your neck out and call that guy a liar? Pretty unlikely. But is that enough evidence for you to call a person a liar and say they're wrong? I don't know.
Do you have to research it?
Well, those are questions that we're going to be asking. What is going to be enough evidence for you?